好，嚟到啦12到14條咯，就有關於一個科學探究咧，係有關於個水草嘅水勢嘅。咁所以呢條題目啦都唔使審啦，都係考翻我哋有關於滲透嘅概念。咁呢3條題目啦都係有關於呢個科學探究啦，我係好中意嘅。一來啦，佢係一個探究啦，想大家咧去思考一下啦；二來啦，佢要思考嘅空間咧，亦都係大一啲嘅。你唔係一步到位嘅。你可能要諗多1步2步先去到個答案嘅，咁呢一樣嘢咧，我係好欣賞。而呢一條題目咧，係源自一條 Excel IGCSE 嘅題目嘅，其實都有翻咁上下歷史噶啦，係講緊2012年過外噶啦。咁過往我都有教學生嘅，咁啊有機會咧，又同大家分享下咯。咁成個實驗啦，點樣做咧？第一步咧就係將啲水草擺落去唔同濃度嘅蔗糖溶液嗰處，咁啊50、15、20% 啦。然後啦，喺各自4個嘅溶液當中咧，我都加幾滴染料落去，我就當啦加啲紅色嘅染料啦。然後啦，就俾佢哋做1個鐘嘅滲透。然後啦，再喺翻呢4個蔗糖溶液當中咧，去抽取1滴染咗色嘅蔗糖溶液，然後再將嗰1滴嘅溶液咧就加翻落去佢本身濃度嘅溶液嗰處。咁即係話啦，本身我喺5% 嘅溶液掉咗個水草落去，加咗個染料，再加翻呢1滴染咗紅色嘅蔗糖溶液，就去翻呢個5% 嘅蔗糖溶液嗰處。然後啦，加落去嘅位置都好講究嘅喎，原來就加落去呢個溶液嘅中間位置，然後再去觀察一下咧，呢個染咗色嘅蔗糖溶液加翻落去佢原先嘅濃度嘅溶液嘅時候啦，佢嘅即時移動位置喎，佢一係就沉啦，一係就保留翻喺同樣位置啦，一係咧就升咗嘅。咁啊，入個問題之前咧，有3個關鍵嘅概念咧，我想同大家解釋咗先。解釋咗嘅時候，你就會識得做噶咯。第一個頭先都講咗噶啦，成件事成個探究想研究水藻嘅水勢，咁自不然就係玩滲透啦。當中嘅關鍵概念，我相信大家都唔陌生嘅，就係當蔗糖溶液同埋水藻細胞之間有水勢階梯嘅話咧，滲透就會發生。就會導致到啲水分子，佢一係就由個蔗糖嘅溶液入咗去個藻類細胞入面，又或者由個藻類細胞出咗去外面嘅蔗糖溶，都係一個正向嘅移動。而無論邊一個過程都好，啲水係入個水藻細胞定係離開個水藻細胞咧，都會影響咗個水藻外部嘅蔗糖溶液嘅濃度同埋密度嘅。示範一次俾大家睇。而家浸住水藻嘅溶液咧，係一個特定嘅濃度 X%， 而個水藻佢自己嘅細胞質啊、液泡入面嘅蔗糖溶液嘅濃度咧就係 Y%。而家我就想比較下 X 同埋 Y 啊，邊個高啊，邊個低啊？1個鐘之後，究竟啦外面呢一兜蔗糖溶液嘅濃度會係幾多個 percent 咧？第一個情況就係兩者嘅濃度一樣，既然兩者濃度一樣，亦即係話呢兩者嘅溶液嘅水勢應該都係一樣，咁有冇滲透發生啊？梗係冇啦。所以啦，1個鐘之後，喂，都冇滲透發生過，啲水係有出係有入，但係冇正向移動啊嘛。所以啦，出面嘅呢一個蔗糖溶液咧，仍然係 X 嘅 percent。然後啦，去到第二個情況咯，就係啦，原來咧 X% 即係浸住個水草嗰個蔗糖溶液嘅濃度咧，係高濃度過喺個水藻細胞入面嘅蔗糖溶液嘅濃度嘅，所以啦就係水藻細胞入面嘅蔗糖溶液嘅水勢就係高一啲咯。如果啦係個水藻嘅水勢高一啲，咁啲水係咪會正向移動出咗去呢個外面嘅蔗糖溶液嗰處啊？所以啲水就會由個水藻被抽咗出去咯。咁即係話1個鐘之後咧，外面係多咗水分嘅。所以啦，佢個濃度其實係咪就會比之前為之低啊？咁即係話啦，本身咧可能佢係15% 嘅濃度啦。咁而家啦，喂抽咗水喎，啲水出咗去喎，佢就有機會咧變成咗14%。嗱，我求其作個數字嘅啫，總之就係低咗啦，濃度就會低咗。跟住啦，去到第3個情況啦，原來咧就係喺個外面嘅溶液咧，佢個濃度係低濃度過喺個細胞入面嘅蔗糖溶液嘅濃度嘅喎，所以咧就輪到外面嘅蔗糖溶液嘅水勢就會高一啲咯，係咪啊？如果啦係外面嘅水勢高一啲，啲水就會進入去個水藻嘅細胞入面。第三，既然啦外面嘅 蔗糖溶液嘅水，喂，入咗去個水組喎，咁即係話啦，外面呢個蔗糖溶液咧就會少咗水分。既然少咗水分，咁即係話佢個濃度咧就會比起之前為之高啦。咁即係話佢本身咧可能係5% 嘅濃度啦。咁喂，咁低濃度，水勢咁高喎，咁啲水入咗個水草喎，咁自不然啦，佢到頭來可能就會變成6%。我都係求其作個數字嘅啫，總之就高咗啦。咁呢個就係第一個關鍵概念。而第二個關鍵概念咧就有關於呢個染咗色嘅蔗糖溶液加翻落去本身濃度嘅蔗糖溶液嗰處嘅時候啦，佢有3個可能性。第一，留喺同一位置唔喐；第二，沉落底；第三，浮上面。呢3個可能性都係建基於啦，呢一滴染咗色嘅蔗糖溶液同佢本身嘅蔗糖溶液嘅濃度嘅差異，同佢本身嘅蔗糖溶液嘅密度嘅差異。因為啦，如果佢係高密度嘅，咪會沉咯；如果佢係低密度嘅，咪會浮咯；如果同樣密度嘅，咁咪唔喐咯。咁呢個就係第二個關鍵概念。跟住啦，去到第3個關鍵概念就係有關於溶液嘅濃度同埋密度嘅關係啦。因為成個實驗好似好割裂噶嘛。哎呀，你又知得到咧嗰個溶液嘅濃度嘅變化，然後睇嗰個點點咧就見到個密度嘅差異。咁濃度同密度有咩關係啊？醫生，我用隔離呢個例子去話俾大家聽。同樣嘅一隻蛋，你擺佢喺一個蒸餾水啊、水喉水咧，佢係會沉嘅。咁即係話隻蛋嘅密度係高過水啦。但係如果我喺個水度加啲鹽，令到佢變成鹽水嘅時候，同樣一隻蛋就擺喺鹽水，佢浮喎。咁即係呢隻蛋嘅密度就低過鹽水啦，係咪啊？鹽嘅溶液啦。所以我哋得出一個簡單嘅概念就係溶液嘅濃度越高，佢嘅密度亦都會越高。因為啦，由水喉水、蒸餾水加咗鹽之後，咦，溶液濃度高咗喎，佢密度都高咗喎。1、2、3，咁隻蛋相對地佢嘅密度就係低一啲咯。咁而家啦，綜合咗關鍵概念1、2、3，我哋就嚟睇一睇我哋實驗嘅結果會有啲咩嘅解釋咯。咁呢4點啦，我標示咗先啦，1、2、3、4。咁第一個染咗色嘅蔗糖溶液咧就沉嘅喎嚇，佢擺翻喺5% 嘅蔗糖溶液之後佢沉喎。咁即係話呢一滴染咗色嘅蔗糖溶液咧，佢係高密度過5% 嘅蔗糖溶液。既然佢密度高一啲，係咪即係濃度都係高一啲啊？咁所以啦，原來喺第一個嘅液滴當中咧，佢嘅濃度高過佢本身5% 嘅蔗糖溶液嘅濃度喎。咁點解個濃度會高咗嘅？係咪就係因為本身5% 嘅蔗糖溶液佢嘅水勢咧係高過水草喎？所以啲水咧就會進入咗個水草，就令到外圍嘅5% 嘅蔗糖溶液嘅濃度咧就會高過之前咯。原來啲水係入咗水草，跟住落去到第2滴啦，即係滴咗落去10% 嘅蔗糖溶液之後咧，佢停留喺同一位置喎。咁即係話其實佢哋嘅密度差唔多。既然密度差唔多，咁佢哋嘅濃度應該都係差唔多。咁代表住咩意思啊？就係有機會啲水冇一個正向嘅進出咯喎。咁即係暗示咗有機會係沒有滲透作用嘅發生咯喎。然後啦，就去到第3同第4滴啦，佢哋都係浮起咗，即係話佢哋嘅密度都係低過15同埋20% 嘅蔗糖溶液。咁即係話密度低啲，咁濃度都低啲啦。咁即係第3同第4咧，實質係被稀釋咗嘅。咁點解稀釋咗啊？其實佢就係喺個水草當中抽咗啲水走，令到佢哋多咗水分，咁濃度咪低咗咯，密度都低埋咯。有晒呢咁多個數據啦，我哋就真係要嚟睇一睇問題咯。佢就話根據翻染色嘅蔗糖溶液滴咗入去10% 嘅測試溶液之後嘅即時位置，咁即係我哋淨係睇第2支管就已經足夠啦。咁下面邊一個嘅敘述係正確呢？咁啊嚟咗擊破咯。第一句就係呢個染咗色嘅蔗糖溶液嘅密度係同呢個10% 嘅蔗糖溶液係最為接近嘅，正正就係頭先我講過嘅嘢啦。所以第一句係正確啦。然後去到第2句咯，佢就話啦，所有藻類細胞嘅水勢都係同呢個10% 嘅蔗糖溶液嘅水勢係一樣嘅。咁我哋又諗下啦，望起上嚟都似似地嘅。咁啊因為啦， 佢真係應該冇乜滲透發生啊嘛，係咪？咁所以啦，啲水又冇話進出咗個水草，咁所以啦，個水勢應該似係一樣嘅。唯獨就係呢一句説話有一個致命傷，就係佢講所有嘅藻類細胞，一棵水草嘅所有藻類細胞都係一樣，真係咁一樣？望下呢幅圖啦，望起上嚟梗係正常不過啦。外面係10% 嘅濃度，水草入面嘅細胞質同埋液泡佢個溶液咧都係10% 嘅濃度，咁即係話 water potential 應該係一致嘅，就冇話特定嘅水進出啦。但係我能唔能夠講所有細胞都係咁樣呢？我唔可以咁樣講。我要提翻大家一個有關於滲透嘅實驗，就係溶血反應。當初我哋將呢個紅血球擺喺唔同濃度嘅鹽水當中，然後再擺喺顯微鏡觀察下佢哋嘅數量啊，佢哋嘅外表啊。咁我哋先睇頭兩個啦，0% 即係純水啦，所有紅血球爆晒正常啊。0.2% 可能佢個水勢咧都仍然係高過紅血球，咁又爆咗啲啦。然後去到0.4嘅時候啦，咦？我仲見到3個紅血球喎，爆咗97個喎，梁 Sir。咁點解爆剩個3個唔爆嘅？係喎，點解爆剩個3個唔爆嘅？又或者啦，去到下面啦，1.2% 嘅鹽嘅溶液，仲有100個細胞喺度，全部喺度喎。咁可能擺喺顯微鏡睇一睇咧，可能係縮晒水啦，係咪 shrink 晒啦，係咪？擺喺1% 都仍然100個喺度喎。擺咗0.8% 嘅時候，咦？得翻95個嘅，即係有冇5個唔見咗喎？喂，嗰5個去咗邊啊？哎呀，爆咗啊！點解會爆咗㗎？你一係就俾人抽水，就應該全部俾人抽水；你一係就入水，就全部入晒水。點解有3個死剩種喺度㗎？點解淨係爆咗5個 cell 㗎？有冇搞錯？其實諗深一層，你就會諗下，作為一個紅血球，你覺得真係所有紅血球嘅細胞質佢哋嘅水勢都係一樣咩？梗係唔一定一樣啦。所以啦，有陣時睇第二句説話咧，我哋就要提醒自己啦。你見到嗰啲咩 all 啊、must 啊、some 啊、only 啊、always 啊、usually 啊呢啲字眼咧，你要小心。我唔係話佢一定錯，就只係嗰件事係咪真係咁極端，或者係咪真係咁概括，會係一個咁嘅情況咧？所以第二句啦，就 say goodbye 咯。而第三句啦，其實就係同我哋嘅第一句互為因果嘅。佢就話啦，10% 嘅蔗糖溶液同埋個水藻細胞之間咧，係冇一個正向嘅水嘅移動嘅，亦即係冇咩啊？冇滲透咯。咁係咪真係冇滲透啊？睇翻呢幅圖你咪知咯。咁我望起上嚟都似冇喎。正正因為浸住佢嘅就係10% 嘅蔗糖溶液，而當中我哋發現啦，到頭來外面呢一兜嘅蔗糖溶液佢個密度係冇乜點變化，咁即係話佢個濃度都冇乜點變化，咁亦都引證咗沒有滲透呢件事嘅發生。所以咧，1、3就係答案咯。Question 12 to question 14 is about the investigation on the water potential of a type of algae. Surely, it's about the osmosis, right? So let's take a look of the procedures of the investigation. Step 1. We place the algae in the sucrose solution with different concentration and add a few drops of the dye solution. For example, we make them red. So all the algae in a particular sucrose solution concentration, and then after 1 hour, use a dropper to obtain a drop of the dyed sucrose solution and add them to the same setup as the setup 1, but with the algae, and transfer the drop of the dyed sucrose solution to the center of the corresponding test solution. And then the diagram shows the position of the drop of dyed sucrose solution right after its immediate movement in the test solution. It may sink or stay in the same position or float. So, before we really talk about the question, I would like to introduce the three critical concepts of this question. First of all, the critical concept number one, osmosis takes place when there is a water potential gradient between the sucrose solution and the algae cells, and there will be net movement of water molecules to or from the sucrose solution outside the algae. So that means the water may either go into the algae or is drawn from the algae. And then the concentration and the density of the sucrose solution outside the algae will change because there may be water go to the sucrose solution outside the algae, or the water will go into the algae from the outside sucrose solution. So I show you the logic of this concept. So outside the algae, we have the X% sucrose solution. And inside the algae, the cytoplasm or the vacuole of the algae, so we have the Y% sucrose solution. So 1 hour later, let's see what will be the concentration of the sucrose solution outside the algae. First case is that X% is equal to Y%. It means it's the isotonic situation. It means both of the solution, they have the same water potential. And there will be no osmosis. Water will go in or go out, but there is no net movement of water molecules into or from the algae. Therefore, finally, 1 hour later, the outside sucrose solution will stay in the X%, the same concentration. And then what about the second case? Hypertonic sucrose solution is the outside solution, and the concentration is higher than that in the algae cells. So it means that the Y% solution, that means in the algae, it has a higher water potential. And then what will be the net movement of the water molecules? It should be from the algae cell to the outside solution, net movement. And then that means the water will be drawn from the algae, and there will be more water in the outside solution. So the concentration of the sucrose solution will be lower. The idea is just like that. For example, outside is the 50% sucrose solution and is much higher concentrated than the sucrose solution in the algae cells. And then the water go out, and then finally it will drop to 40%. Just a random number, okay? But the sucrose solution concentration, it drops. And what about the third case? The X% sucrose solution is hypotonic, lower concentration than the sucrose solution in the cytoplasm, in the vacuole of the algae cells. That means the X% solution have a higher water potential than the Y% sucrose solution. So if we know that there is such water potential difference, so there will be net movement of water molecules going into the algae cells. And then because there is less water in the outside solution, so the concentration of the outside solution will be higher. It's just like that at the very beginning, or the water potential. For example, at the beginning, the X% sucrose solution is 5%. Concentration is just lower than the sucrose solution in the cytoplasm or the vacuole in the algae cells. So the water will go in due to the water potential gradient. And because there will be less water in the sucrose solution, and then the concentration of the sucrose solution will be higher, let's say 6%. So that's the critical concept number one. And then for the critical concept number two, it's about the possible position of the drop of the diluted sucrose solution, either stay in the same position, sink to the lower position, or flows to the higher position. It depends on the density difference between the drop of the diluted sucrose solution and the testing sucrose solution. So you can see that for this drop of the diluted sucrose solution, it sink. It means that there is a higher density. And then for these two drops, they float. It means that the density is lower than the testing solution. And after that, I want to talk about the critical concept number three. We need to link the concept of the concentration and the density of the sucrose solution together. Because for the critical concept number one, we focus on the concentration of the sucrose solution. And for the critical concept number two, we focus on the density of the sucrose solution. And now we need to link them together. I use this as the example. the same egg, if I put it in the fresh water, no solute at all, the egg will sink because the egg has a higher density than the fresh water. And what if we add some solute, the salt, in the water, make it salt water or salt solution, and then the same egg, it will float. It means that the egg become less dense than the salt solution. So the critical concept number 3 is talking about the higher the concentration of the solution, the higher the density of the solution is. So let's combine all these 3 critical concepts together. So let's understand the result. So I extract the drop of the diluted sucrose solution and then add it to the testing solution. I can find that drop 1 sinks, drop 2 stay in the same level, drop 3, 4 float. So for the drop 1, it sink. It means that this drop of the diluted sucrose solution is denser than the 5% sucrose solution. And because the density is higher, it means that drop 1 diluted sucrose solution is more concentrated by the 5% sucrose solution. So think about it. Why the drop 1 it become more concentrated? Because the water get into the algae and make the solution become less water, contain less water, become more concentrated. And then for the drop 2, it's staying at the same level. That means they have similar density or same density of the 10% sucrose solution. So it means that drop 2 is almost concentrated as that of the 10% sucrose solution. So what does it mean? It means that there should be no net movement of water molecules going in or going out of the algae. And then for drop 3, 4, both of them float. It means that their density is lower than that of 15% and 20% of the sucrose solution. So it means that drop 3, 4 are more diluted than the 10% sucrose solution. So what does it mean? It means the water should come from the algae to the outside solution. Water is drawn from the algae to the outside solution and then dilute the solution. So after we analyze the result, so let's take a look at the question. Based on the position of the drop of the diluted sucrose solution, right after its immediate movement in 10% test solution, it means we only need to focus on 10% sucrose solution. Which of the following statement is correct? So let's take a look at the option one by one. First of all, the density of the diluted sucrose solution is closest to that of the 10% sucrose solution. So as what I say that because the drop stay in the same level, not moving at all, therefore the density should be very, very close, maybe even the same. Statement 1, correct. And then for the statement 2, the water potential of all algae cells is equivalent to that of the 10% sucrose solution. So you may think that, yeah, Mr. Leung, as what you say that there should be no osmosis, right? So it means that they should have very similar water potential or even same water potential, right? But for this statement, there is one thing we need to be aware is the terms all. Do all the algae cells, they really have the same water potential as the 10% sucrose solution? I would like to recall one experiment for you in osmosis. It's about the hemolysis. We put the red blood cell in different concentration of the salt solution and then put them under the microscope to count the number of cells. We can still see them or we can observe the appearance changes of the red blood cells. First of all, you can find that for the 0% of salt solution, that means pure water, and then no more red blood cells appear. All of them disappear. Why? Because water will get into the red blood cell by osmosis and then all the red blood cell will burst. And then 0.2% still no cells appear because all cells burst. But what about 0.4%? You can see that I can only see 3 of them. It means that 97 of cells, they are gone, they burst, right? And my question is that if the 0.4% solution can make 97% of red blood cell to burst, why not the last 3%? They should all burst or they stay intact, not burst at all. And the same idea, if we take a look at the 1.2% salt solution, we can still see 100% of the red blood cell. All of them still appear, but they may shrink because water is drawn from the rubber cell. And 1%, and then we can still see 100% rubber cell. But what about the 0.8% of the salt solution? I can only see 95% of rubber cell. So what does it mean? It means that 5% of the rubber cell, they disappear. Maybe they burst. So what I think is that, how come if they burst, they should all burst? If they shrink, they should all shrink, right? Not really. Because you really need to ask yourself a question. Do all the rubber cells, they really have the same water potential? No. From this experiment, we know that all the rubber cells, maybe we extend the idea to the plant cells, that all the algae cells in the same algae, they do not have the same water potential. And I also tell the student that when you see the statement, with the wordings all, only, must, always, usually, or some. So you need to be very, very careful. And I do not say that this kind of statement must be wrong. They could be correct, but you really need to think twice. To think about that, is it the case so extreme or is it the case so general? And now you can see that statement 2 is wrong. And then for the statement number 3, there is no net movement of water between 10% sucrose solution and the algae cell. So you can see that statement number 3, it echoes statement number 1. They are interrelated because the case is just like this. For the 10% sucrose solution outside the algae, actually the algae cells, they also have the same concentration of sucrose in the cytoplasm of the vacuole. Therefore, there is no osmosis. No net movement of water molecules in and out of the algae cells. Therefore, for the outside sucrose solution, the concentration doesn't change at all. That's why the density doesn't change at all as well. Therefore, when we put them in the 10% sucrose solution, so it just stays in the same position. Therefore, answer will be 1 and 3.